Hi,
Okay.
I'm Thomas Brent.
I'm Andrew Thompson.
This is Concept Map 3, 131A.
Yes. Oh, do you want to get your computer so we can prop it
Oh,
up?
yeah.
Okay. So we've added a lot of stuff. We redid our concept map because it was getting pretty crowded with a lot of concepts. So the first thing, the big thing, our big connections are still going to be between stress and strain. That's the big, I think those are the kind of the center focus of 131.
Yep.
And then a big thing we've added is more circle, and then we have our, what did we call this? The stress. Evan, what's that little square called with the arrows coming off of it that I told you?
State of stress?
State of stress, yes, thank you. So we have the state of stress here. So this is our positive. I've included the positive.
Proper sign convention. Positive sign convention.
Yeah, the positive sign conventions here. So that's going to be really important because that's going to throw off your answer if you're off a little bit. So we've added that. More circles related to that, which is a way to graph this. So obviously that's going to connect.
We just learned that in class. I find also more circle is on the homework. There were some questions that it's kind of confusing. They were asking for two different angle dimensions, and it's really hard to try to visualize that and the quadrants and stuff like that. But I think more circle kind of can help you with that and understand the angle relations and what when we should add 90 degrees or add 360 degrees or whatever to find our different angles that we need.
Yeah. So we also have the plane stress and principal stress, which are related to this as well, but they connect through a long chain of goes to stress, which goes to strain, which goes to here. But anyways, so the principal stress also has the tangent 2 theta equation.
Yeah.
We didn't write that full equation on here because it's quite long and obnoxious.
It's important to know, though.
Yeah, so the principal stress is going to be found when looking at, you're taking a big sample and zooming in at a micro scale onto this particle and analyzing the forces onto it. And then
I feel like a lot of this content is, at least for the homework, a lot of it is kind of plug and chug. I mean, it's kind of weird conceptually trying to think about these things because it's like a microscopic image of kind of what we're looking at for a stress I don't know. To me, it was weird to visualize and try to understand what the angle means when you're rotating or
yeah.
So it is still important to understand why we are using these equations and where, but for the most part, I didn't think this part was too bad. I don't know.
Yeah. No, it is very pluggy and chuggy. But I think you have to understand what they're looking for. So if they're looking for the principal stress, that's going to be different than the angle, or if it's looking for the plane, that's going to be the angles, the angle 1, angle 2, whatever. And important to keep in mind the double angle. Pretty much all that is going to have a 2 theta in there. We can add that to the map after this, actually.
Yep.
But so I guess that all connects to deformation too. It's all kind of related to that bending, statically indeterminate.
It's on the test.
Yeah, exactly. And then we do have the selfish equation. I don't know if that was covered in the last one. I think that's new.
Omega is equal to negative my over I.
Yeah, so she described this as the selfish equation, negative my over I, so it's bad to be selfish. But that's finding the maximum stress, right?
I think so.
Yeah, and that connects to moment of inertia has been a big concept recently. And then we have this equation, the negative VQ over IT for the shearing stress, correct?
Q being moment of area, V is shearing, I is moment of inertia, T is the thickness.
Yeah, and then so we have Q is equal to the centroid, the distance from the centroid, which is the normal axis. We could also put normal axis on here, times A prime, which is going to be your area of your normal. A lot of this connects to moment of inertia because now that we're looking at stuff, the mass is going to be concentrated in different factors. We're looking at rigid body, a lot of stuff like that. So we could go ahead and add rigid body here as well. But yeah, I think that's a good overview of what we've gone over recently.
We won't go over the old stuff. 'Cause
Yeah.
there's a lot. But
Radius of curvature.
Yeah.
If you're looking at the bending, the radius of curvature of something bending, we have that. So that's another moment connection and the moment of inertia. So yeah, I think that about sums it up.
good stuff.
Alrighty, thank you.
Thank you for watching.